And now I have the privilege to introduce Mr. Balaji Rangaswamy, who is moderator of the panel. And Mr. Balaji Rangaswamy is CEO and co-founder of Sooktha, a Bangalore-based 4G, 5G solution provider. With 24 years of experience in telecom and cellular wireless industry, Balaji has deep knowledge of 3GPP, cellular wireless technologies and specifications. Within TSDSI, he leads special interest groups focused on privacy, personal data protection, and the proximity processing. So that is what we are discussing. And thank you very much, Balaji. Over to you for proceedings of the panel discussion.
Thanks, Akhilesh, and good evening, everybody, and welcome to this panel discussion. We are continuing from where Akshay left off, and also related to the topics that Anand and Sachin covered earlier in the session, talking about privacy challenges and solutions when it comes to pandemic technologies. Of course, contact tracing is one of them, but we'll also discuss a few other use cases, what the challenges specific to them would be. Since we are already behind time, I will quickly introduce the panel. Sachin, Anand, and Akshay, who presented in the keynotes, they're all joining us back on the panel. Welcome back, Sachin, Akshay, and Anand. And also joining us on the panel today are Dr. Giri Mandyam from the West Coast in the US. Dr. Giri Mandyam is Chief Security Architect for IoT products, Qualcomm, formerly also has served as chair of the geolocation work group in W3C, so no stranger to geolocation, location tracing, and all the contentious issues around that. So, and also joining us is Professor Kamakoti, Professor of Computer Science and Engineering from IITM. He's somebody who has been very closely associated with Arogya Setu. And so welcome, Dr. Mandyam, Professor Kamakoti, welcome to the panel today.
Yes.
I would like to start off, since there was so much discussion about Arogya Setu and contact tracing. I would like to start off the panel discussion by requesting Professor Kamakoti, since he was closely associated with the development, to briefly present his views and his experience with Arogya Setu. Professor Kamakoti, please.
Sir, if you can share your video. Are you audible, sir? I think we can't hear him. Can you just refresh your page, or he left the stage?
Yeah. Am I audible?
Yes, Professor. Please.
Are you uploading the slide, or I should do that? I've actually sent the slides to you. Yeah, anyway, I'll do that. Yeah. Okay, thank you for this opportunity. I just wanted to share this experience of building a large-scale data-driven system, taking case study as Arogya Setu. So the entire project was actually very interdisciplinary in nature. So we had computer scientists, basically software development people, along with AI ML people. Then we had epidemiologists. Then we had statisticians, and then humanities and social science people who also pitched in to talk about many of the things there. And we had legal, specifically handling the privacy issue that is talked about. So we had a time window of around 25 days to launch this entire thing from scratch. And I would like to take you through very quickly in the next 5 minutes on what we had done. So the entire development cycle was followed. There was SRS, there was functional testing, performance testing, security testing. Then we went for a deployment. Then we had all the end user acceptances, then usage. Then of course there was a backend which actually used the data that was collected to make certain inferences, and all these things I want to present as a part of this case study. So the basic thing was that when we looked at this application, yes, there was an edge, which was the Bluetooth that we could use at that point of time, the only available technology that people knew about it at that point. And then the intermediary was a mobile phone, and the cloud, of course, is the backend. So the only intuition which came was COVID, of all the uncertainties that were there, was certain to spread through contact, and that is measured as a function of proximity and the time spent at that proximity. So these two are the most important thing. And then there were epidemiologists who discussed about this thing, and that was actually translated into a Bluetooth contact tracing algorithm. So the edge was actually a Bluetooth sensing mechanism. Very simply, to user A and user B both must have installed Arogya Setu, and they should keep their Bluetooth on. And what we do is that the moment they register for Arogya Setu, they are given a DID, a unique DID, which is different from their mobile numbers, and that is not known to anyone else. So we anonymize A and B by assigning unique ID to each of these mobile number, and it is unknown to anyone else. And if A comes in proximity to B, the distance is recorded and the time of contact is also recorded, along with the location information in both the mobiles, along with the unique ID of the other. But in this process, A will not know B, and same for B will not know A. The common link will be the unique ID. Unique ID of B will be stored in A, and unique ID of A will be stored in B, and that too as in an encrypted format. So this is what we thought, along with the distance and the time, and also the location information. Now, the location information becomes extremely important here. I'll come and explain that little later, but then we will take it. So the main thing was, even from day one, when we started debating about this app, privacy came first and the security next. The security is important here because, of course, there's some amount of personal data that is being collected, like name, age, whether they had a comorbidity, etc. And also the profession, because we want to know whether, we have to say if there are a health worker or a bank person who has to go out versus somebody who need not be exposed to the public. So, and the most important thing is that when A and B had come too close to each other, A's mobile ID will be stored, unique ID will be stored in B, B's unique ID will be stored in A, and when one of them tests positive, then from A, from A's mobile, the complete proximity information will be uploaded to the server, and all the people who are in proximity to A will be notified, saying that they are in risk because they came in close proximity to someone. So B will not know it is A will not know who is B, but B will know that he has come in close contact to someone who tested positive, so that they could go and test and take certain precautionary measures. Now, the question that also came in, who should certify that somebody is actually COVID positive? We wanted to keep it in the central server for the simple reason that, somebody wants to, if we allow self-certification of, somebody becoming positive, then this can also, we saw a potential problem that somebody can actually go with a mobile and stay in a very close proximity area, become close to many, and then if they, just for fake, they can say they are positive, and then many of them will be shown as positive, and this can be creating a chaos. So we wanted a centralized server to certify that somebody has become mobile, because we saw that this can become a fake information propagation, which can basically create chaos. And this was also one of the important factors. Just I want to tell the audience that what went in our mind. Now, the intermediary was the mobile phone, and through the app stores the sensitive data is encrypted form and interfaced with the cloud. And this intermediary, if somebody is not at every 15 day, it discards the old data. And it also allows user to upload self-assessment with symptoms like I have cough, I have fever, I have loss of taste/smell, I have difficulty in breathing. And this data is basically sent to the central server along with the latitude and longitude information. Okay, so this is the intermediary work. At the cloud level, the cloud accepts self-assessment of data. For all positive tested patients, they will confirm whether they are positive. They do it rather than the user do. In some other countries' model, the user self-certify that they have become. So that had a problem that I was mentioning earlier. And there is an epidemiological model that analyzes the contact trace information to classify each contact as high risk or moderate risk or low risk. And this will send information back to the mobile of the trace DIDs on the classification. And this also give additional information to users like infection spread in the proximity and where are the nearby test centers, etc. So these are all the cloud level information that is being provided. So, so on the actionable item side, so around 200,000 self-assessments or traces per day we started getting. And so a single entity cannot follow up this. So how do you physically reach people and ask them? The system is useless if we do not have follow-up action. And that is precisely the reason why we wanted this location information. So what we did with the lat long is we mapped the lat long to a state, to a district, to a pin code, to a sub post office. India has 1,55,646 sub post offices. We marked down to the sub post office so that this was the information could be given to these people so that they go and follow up. They call them. The health workers actually call them and take remedial action. If they want to do a test, they ask them whether they are fine, and this type of a thing could be done, and this is actionable. So for every sub post office, we had a latitude, longitude. So we matched on to the closest lat long, and so that particular district, that particular sub post office can take an action. So we actually form a grid-based system, and we map the lat long to these grids. But this is a very small grid, but it's a very large grid that 1 kilometer cross 100 meter cross 100 meter was the grid on which we mapped. Now, after that, we started deriving some insights based on the calls received, based on the contact tracing. We were able to do a syndromic mapping, and that syndromic mapping. Again, we could classify that syndromic mapping to a sub post office area, and at a later stage to an area of 10 meter cross 10 meter, 100 meter square, wherein we go and say that based on the information that we have collected, the assessment that has come, this particular area is very high risk or high risk, moderate risk, and low risk. At least 4 levels we could classify. And please note that only aggregate information was provided even to the health worker in these cases, and no personal mobile information was provided. Only for people who have asked for self-assessment and they say they have cough and this, there is a clear consent that was put there, which says that we can share your details with the health workers, and this was given to the health workers. And there were 3 levels of security that was put at the NIC to safeguard this data. So, and what this has done, right? It has enabled the catch early and contain early protocol. This was conceived by Ahmedabad Municipal Corporation and further adapted by multiple districts of Gujarat and also other states across India, right? And the effect of this was, so some of these articles that I could show you. So this was something that, as you see, that the drop June 5th, there was a bigger state in Ahmedabad. From June 17 to July 17, the data revealed that cases has come down by half, and the deaths have dipped from 22 to 5. So from June to August, or June 5th to July 17th, right from somewhere around 400, the cases came down to 100, and some 40 deaths to 5 deaths. And this is because they were able to take these spots and basically go there and take some remedial actions. And so this is, I just given me this 5 minutes time. I just thought that I need to present. And there were many other articles about this entire software that had come up. With this, I conclude, and then we can take up later questions if there are. Thank you very much.
Thanks, Professor Kamakoti. I have a few follow-up questions, but before we go to that, I sort of want to set the stage for the discussion. And at this point, I would like to bring in Dr. Giri Mandyam. We have had quite a bit of discussion on contact tracing. They presented it, and just now Professor Kamakoti presented about contact tracing. But are there? I'm sure there would be other use cases where the standard operating procedures of pandemic management tasks could be automated or assisted by technology. So I would like to ask Dr. Mandyam if what are his views beyond contact tracing. What would be some of the use cases or applications, and would they all sort of suffer from similar privacy concerns like contact tracing?
Well, I think we've seen a lot in a lot more adoption in telemedicine, particularly in the U.S. During the past 6 months. Doctors and their patients have been using standard personal technology to reach out and schedule appointments, basically avoid putting people in the vulnerable position of having to go to doctors' offices and hospitals where you may have a lot of sick patients who are in physical proximity. And those technologies, I think those technologies are very good. They've also highlighted some of the shortcomings that we've had with, particularly in the U.S., with our commercial broadband to the home. And it's probably going to be a motivator, in my opinion, to accelerate the deployment of 5G cellular networks. Right now, I think particularly for medical analysis, and of course, I'll preface with I'm not a doctor, so I'm just basing this on my observations. Quality of experience on live video sessions is very important for accurate diagnosis, particularly if patients are having to show different body parts or display different ranges of motion or anything visual to the medical service provider. And right now, a lot of the commercial ISPs are not fulfilling their responsibilities to the consumer to provide a minimum level of bandwidth guarantees, particularly for these kinds of services. On cellular, though, there is a capability to do that, mainly because there's differentiated quality of service on the air interface, and it could eventually be that this could lead to medical service providers eventually getting their own classification for their traffic over cellular service, similar to what you have with first responders today, who already get preferential quality of service treatment. So I think as telemedicine starts to make more use of technology for remote sessions between doctor and patient, I think you'll start to see more and more people turn away from traditional broadband to the home and start to move over to some of the emerging wireless wide range technologies such as 5G in the future. Thank you.
Thanks, Dr. Mandyam. So a follow-up question, have you seen any specific trust concerns or privacy concerns with the increase in telemedicine, because there is a lot of personal health information that's being shared? Any specific trust or privacy issues that have come up during the pandemic?
Yes, I think one thing that I think is a little bit maybe confusing to to patients is that there's a wide variety of video conferencing tools available, and there's no consolidation in this space, and there isn't a reliable way for the end user to be assured that the information being exchanged between the patient and their medical service provider is not being used for other means. There's not really any assurances that can be provided to the user right now. I don't have a perfect answer for that. It's a long-standing problem, and I think this actually, I spoke to the panelists earlier this week about this. going back to my days as chair of the geolocation API working group in the World Wide Web Consortium, I used to always get requests to say, can we not in the browser be able to show for a particular website what that website is going to actually do with the geolocation information being obtained from the user? And the fact of the matter is that that's actually that actually can become an abuse vector. A hostile third party can lie to the user and tell the user, I'm not going to use this geolocation information for any other purpose but the purpose of the service, and it could be a total lie. So I think that's been something that is a shortcoming of the technology industry, that we haven't been able to find a better way to actually provide assurances to the end user that there won't be an abuse of his information, or there won't be a violation of his privacy in these particularly in telemedicine sessions. But like I said, I don't have a good answer for that right now. It's something that the industry still needs to continue to strive to work on.
Thanks, Dr. Madras. Anand, you mentioned that you're working on proximity data processing and matching user preferences. Have you seen any use cases apart from contact tracing that help in pandemic management, say vaccination tracking, or managing the pandemic enterprises? Any other use cases? You're on mute, Anand. You'll have to go.
Yeah, sorry about that. Okay, am I audible now?
Yes.
Okay, so I'd like to approach that question by sharing. If you look at contact tracing, so contact tracing essentially as an application has uses certain underlying technologies, which essentially technologies like geo-tracking and personal or peer-to-peer proximity-based communication. Which the specific application for contact tracing is Bluetooth based. But if you look at the history of some of these technologies, I mean, they've been around for a long time. In fact, peer-to-peer proximity technology, it's been used by for many years for various consumer-facing applications, like sharing of files or sharing of high bandwidth media. We had some very interesting uses of file sharing, in India. When you go beyond before today's context, when 4G is all pervasive, right? When 3G was just coming up, we had some very interesting uses of file sharing using peer-to-peer. And there were also applications for personal communication, which used to the world witnessed in certain global events when the internet connection was shut down by the states, and people used this proximity peer-to-peer communication for just connecting people around them. So and now if you look at today's context, some of these applications are in the domain of device authentication, device pairing, pretty much all devices today, whether it's with Bluetooth or Wi-Fi or related technologies, use some form of peer-to-peer proximity communication for authentication. It's also being used for in some applications in payments. So these are this is what some of these applications have led to today, and I believe that as we look at future, the contact tracing underlying technologies will be used in various ways, both in the enterprise business domains as well as in the public domains. In the enterprise domains, we are already seeing so through some of the work that my company is doing. We are working with some companies to provide workforce safety, ensuring that the workforce is safe, by and maintaining safe distancing. Today, there's an ability to trace contacts of the employees. Some businesses are using these technologies for visitor management. So when visitors arrive at the campus, a trail of where these visitors move to. In the public domain, I think we will see uses of this in in public disaster management, and also in some of the vaccine post-COVID phase, vaccination management, some of the applications that Akshay had referred to in his talk. So certainly, I think there are the underlying technologies essentially will find many uses.
Thanks, Anand. So it looks like the way I see it is that, especially during the pandemic, there are a lot of use cases, and we discussed about the accuracy of Bluetooth location tracking. So it looks like on the one side we need greater granularity of location tracking accuracy. Would like to track the location of the users constantly, and at the other end, privacy seems to be a big concern. At least we have discussed that Arogya Setu, particularly, it has been one of the reasons why we have been mentioned. I would like to bring in at this time, Dr. Lodha, you mentioned some very interesting research about cryptography, preserving privacy, the different methods. How do you see some of these? Are they going to help address the increased privacy concerns? Can they help address the concerns with the increased data and the increased granularity that's being shared? How does some of your research bear on this problem? But can it mitigate at the same time addressing the privacy concerns?
Yeah, thanks, Balaji. No, see, I mean, there is privacy, there is also utility side to this, but we also have to look at the scale, right? So, for example, when we talk of country of our size, right, with 1.4 billion people potentially, right, that we want to cover, I think scale comes in big time, especially some of the use cases where you may want a very speedy sort of decision, right? That will matter, right? So how quickly you want the decision, whether some of that can be done offline, right? Or how much of it has real-time component. So there are a variety of these factors which will come in, right? More importantly, we also have to look at the threat models here, right? That whom are we trying to protect from? So one of the interesting thing about privacy is that in a typical security scenario, you basically have user and attacker as mutually disjoint people, right? These are mutually disjoint set. But with privacy, essentially, user is also an attacker. And that is the real challenging or tricky part of handling some of these privacy problems. For example, if we look at contact tracing app itself, right? Application developer could be a threat actor, right? Where maybe something is planted in the application that could be leaking information. So how do we discover that and mitigate that? The entity that is collecting data, in this case government, right? We under scanner because they may misuse it. We have to really understand where the threat lies. In terms of the foundational math here, right? I mean, there is a lot available. For example, there is secure multi-party computation possibility, right? So when I spoke of federated learning earlier, right? Multiple parties are computing a function, and how do you allow that computation without no party having to reveal its data to any other party, right? Because it's completely untrusted model. So yes, so those kind of secure multi-party computation protocols can come handy. Of late, there is a lot of work on this employing fully or somewhat homomorphic encryption kind of technology, right? I mean, the crypto methods that could be useful. But see, I mean, multi-party computations have high messaging complexity. Homomorphic encryption have a lot of computational complexity, right? So depending on the threat that is perceived, right, in order to de-risk that, and depending on the underlying deployment architecture, whether it's a kind of centralized versus distributed, right? I think those decisions have to be taken. But we have seen people utilize them judiciously, right? Not always for contact tracing, but we heard Professor Kamakoti talk about a way of doing it, right? And it probably has mitigated certain threats, while maybe some residual threats might still be there. I think it's typically a balancing act ultimately that we have to do. It's a no free lunch theorem, right? So something or other may have to give away, but still a lot of work is available on the encryption as well as multi-party computation side. That seems pretty applicable for this scenario.
Thanks, Dr. Lodha. So at this point, I would like to ask a related question to Dr. Mandyam. So Dr. Lodha did mention that there are some of these methods that could be applied for preserving privacy, but he also did mention that some of them have messaging complexity, some of them have compute. With respect to your IoT products, have you seen, what has been your experience? Have you seen an increased requirement for features of cryptography features? And we also, Akshay mentioned about smartphones not being the only means of contact tracing or proximity detection, but also low-cost devices. So the cost is a trade-off, but is there something happening on keeping the cost the same while bundling more cryptography or privacy masking features into devices?
Yeah, we have made some progress in decreasing the cost, particularly hardware implementations of advanced cryptography algorithms. There are still some concerns about making cryptography algorithms what they call quantum safe, mainly because quantum computing is expected to become something more relevant in the future, and IoT products, unfortunately, for better or worse, have a very long shelf life. They sometimes you'll see the same semiconductor products intended for the IoT market still being sold 2 years after they were first manufactured. I've even heard as much as 15 to 20 years for projection of the sales lifetime of these products. So that, I think, is something that's made a little bit hard for particularly those in the semiconductor industry to predict, is how we actually invest in quantum safe crypto while still being able to meet our price points. But I think I think there's some other things. There's some homomorphic encryption was mentioned, and that's something I've generally looked at as a technology that's better applied in the infrastructure side than on the device side. And the problem is a lot of IoT devices, and some even used in the context of medical services, don't have internet connectivity, and therefore, if homomorphic encryption has to be a viable candidate for those kind of services, we would have to bring some of that computing power over to the edge and possibly within the user's home network, particularly if the devices the user is interacting with do not have internet connectivity. So that's been that I think is not something that's necessarily that trivial to solve, and I think it's pretty challenging going forward.
Thanks, Dr. Mandyam. So I think the buzzer was fine. Yeah, thanks, Asif. Akhilesh, can we take another 5-10 minutes to wrap up? And is it okay with the panelists?
Yeah, I think we could take another 5 minutes, and maybe 7 to 10 minutes is fine, because we are 21:12. So let's wind up by 21:30. So,
okay.
So that is including everything, including the final wrap up.
Okay. Okay, understood, Akhilesh. Thank you.
Well, I think we are at an important discussion point, so let's stop here.
Okay, sure. So I will just ask one question to Akshay and then go around the panel for closing views. That's okay with you. And we should be able to wrap up in the next 8 to 10 minutes. Akshay, so leading off what Dr. Lodha said and Dr. Mandyam said, and you mentioned variables. So looks like there are a lot of trade-offs, and you mentioned privacy preserving. So what has been your experience as to with respect to masking or cryptography? Do you rely on the gateway, or have you been able to achieve that within the devices? So architecturally, what are the options that you have seen where the functionality could be shifted around and still privacy could be preserved?
So how we approached the problem was mostly in terms of using a Bluetooth-enabled Cortex M4, which could do the contact tracing. So it had limited capabilities in terms of computation. However, it has encryption. It has a reasonable amount of computing power to communicate with dynamic IDs. That was one thing that we used. I think Professor Kamakoti mentioned that there is a dynamic ID which is used, but what we realized in Arogya Setu is the MAC address is not anonymized, which we believe can be potentially a hazard if somebody wants to abuse that. And that is something that on low-end devices can be done in terms of anonymizing the MAC address. The communication so centralized and decentralized being two approaches. If the contact tracing for low-end computing devices will have to rely upon a centralized mechanism, and there the issue in terms of communication with the backend, the encryption there is, while there are documents, there is data available, but if you need to keep the device low cost and hence affordable, what happens is you cannot put too many of communication medium and channels on the device, which again puts constraints in terms of how you're going to send the data to the backend server. And that challenge is something you either require an intermediary or some gateway which can capture this data and send it to the backend server where you can store it. But if there is any gateway, it can lead to compromise in terms of knowing who was in proximity, and the data transfer, while the Bluetooth ID can be anonymized and data can be dumped, but the physical sharing of data, the physical location may give away. And I think there is we're not been able to solve that in terms of doing a completely privacy preserving and doing it on a device which does not have its own ability to reach out to the backend as well as to a local computation using BLE. I would like to end, while I'm saying this, I'd like to also add to the earlier, I think there was also a question and it was mentioned about the accuracy. So BLE is, I think, the best among the evils available for communication, because accuracy is poor, but it unfortunately is the only interface available for communication. So there were other mechanisms which we explored. There is data available in terms of audio, in terms of ultra wideband, in terms of IR, but none of these were reliable to a scale to which BLE can cater to. But I frankly don't have a solution that these SOPs are going to ensure that there will be a completely privacy preserving and allowing user to voluntarily disclose and still have an efficient solution. So that I don't have a solution. We try to go as close as possible. All the algorithms that we have developed are available for scrutiny, but I think there are limitations that need more work.
Thanks, Akshay. So, Akhilesh, just 2 minutes then to close with a final question to provoke the panelists. It looks like there are a lot of trade-offs. There are a lot of solutions available, but there are a lot of trade-offs, conflicting factors. But at the same time, it looks like privacy is going to be a concern, will dominate the discussion. There also are different architectures and protocols. So what is the way forward? Is there is so much of fragmentation, and once the global travel opens up, is there any hope for standardized architectures, mechanisms which are interoperable? Is there a role for standardization, or is that an impossible target to achieve? 20, 30 seconds, closing comments from the panel, please. We can go around the table. I will ask Dr. Mandyam first.
Sorry, could you repeat the question? What was the question, please? No.
There's just a lot of fragmentation. There are a lot of trade-offs, different architectures. Privacy seems to be more of a trust deficit issue, probably not so much of a threat. So once the global travel opens up, are there hopes for interoperable, standardized solution architectures for contact tracing or for health monitoring, for accessing health records? Is there too much fragmentation in the architectures and approaches, or is it worthwhile chasing the uniform interoperable solution architecture?
I think it's. I think a lot of the things we've seen with contact tracing and the uptake and the success, particularly of remote monitoring, it seems to be very culturally driven. So I don't really think. I don't really think that it having a one-size-fits-all solution across the world is really going to be that useful. I think there needs to be, the approaches that have worked very well, like for instance in South Korea, I think would be very difficult to get to work in the U.S. So I think maybe it would be certain regions would be better with more of a voluntary approach to contact tracing, where the consumers of the information would actually try to project on the spreads of communicable diseases, while cultures that are actually a little bit more in lockstep would be able to benefit from more than just a common solution, but a government-run solution for contact tracing, more centralized solution. So I don't believe we can ever get to a one-size-fits-all, because I think the willingness of different populations to actually participate in contact tracing programs vary so much across the world. Thank you.
Dr. Lodha, some comments from your side?
Yeah, I agree with what Dr. Mandyam just said. I don't see any one-size-fit-all. I have also seen discussion about incentivizing people to use contact tracing apps or get themselves tested, right? So government could even pay people or subsidize something in order to get them involved, right, and improve the participation. Maybe some of those ideas also need to be looked at, which will be important. See, health data is very sensitive information. In fact, certain countries, like for example, Australia, the health data of Australian citizens could not be stored outside Australia, right? It can't be taken out. And I think in this particular case, because there is also location information associated, in some sense, social graph information is being shared or created. I think there is an additional sensitivity to this, and different communities, different countries will have a very different take on that. So in the light of that, I think we probably have to live with this kind of very mixed solutions, right? But that probably seems to be the state of affairs for some time.
Thanks, Dr. Lodha. Professor Kamakoti, based on your experiences with Arogya Setu, comments from your side?
At least a pandemic where we can't say we will not do contact tracing. There's a necessity to do contact tracing. I go to a cinema hall with my wife, that's a privacy issue. But I go with COVID and I am asymptomatic, I don't know whether I have this COVID. That's a moral responsibility that comes. So all these privacy concerns should be seen with that aspect. I actually request the panelists, if they have a time, to look at Arogya Setu, what we have built up. That could be a starting point. given the situation like India, the scale that Sachin mentioned, and the type of society we are living in, and we need to have an actionable, effective app, right? And what could lead to that actionable, effective app? So, what are the improvements that could be done? That could be a very nice starting point for us, and let us debate and find out which will work, which will not work, right? So, but somewhere this has to be there because there is a collective responsibility of the society. See, we share everything in social media, right? What is missing? What is missing? Tell me. Sambar I did the morning, so the photo is there in the social media. Okay, so that is the collective responsibility. Let us see how we need to address this responsibility, right? And I think that is the way we have to take it forward and come to some amicable, good solutions, right? Certainly, some institutions giving 1 out of 5, 2 out of 5 for our app at some very crucial moments have killed this app significantly. The adaptability of this app, so it caused a lot of commotion and other things. And we had actually opened up the source code and put it right for everybody to watch, right? So I don't think we can be more transparent in that. Okay, this is what we need to go by and do that, right? This is my request to all people, learned people who are talking about privacy. Let us start and look at this. This is not an easy problem to solve, but then we can't say I won't do it. And then there are other threat models and scalability. Thank you.
Thanks, Professor Kamakoti. Very interesting to hear that the ratings created a trust deficit and influenced the adoption. I think Akshay has already described the fragmentation for us. So, Akshay, if you don't mind, I will ask Anand to make the final closing comments, and then we could see if we can take any questions or we could wrap up the session. Anand?
So, yeah. Yes, Balaji, thank you. So, I just have a couple of parting thoughts here. Firstly, I think when we look at addressing some of the challenges that we have discussed on the panel today, and if we look at it also in the India context, because that's something which I think all of us have the opportunity right now to make the maximum impact. I think this whole dichotomy that we are discussing, centralized versus decentralized architectures, effectiveness versus privacy, I don't think we really have a choice, in dealing with, the current situation and probably future situations, would be similar. I don't think there's a choice and decisions. I think these choices have to be made, in tandem with each other. So, for example, looking at a centralized versus decentralized architecture, I mean, both have pros and cons. When it comes to factors like time to deploy, the actual effectiveness, the control that the entity or that is deploying this has on the to cause impact, and of course the privacy, right, as a factor. I mean, so we have to look at the pros and cons and work in a manner in which these architectures can coexist. Similarly, effectiveness and privacy need to coexist. And I think, I mean, just looking forward, the question about standardization that you asked, I think standardization can definitely play an important role, I believe, in ensuring that, all the data that we, been able to generate through this, Professor Kamakoti also shared, and the knowledge around it, based on analysis and insights that we've derived, how they are shared between the different stakeholders, right, including the user. So the sharing of the data, that can be standardized and of course leading to trust, security, and also compatibility. When it comes to the various entities that need to use the data. So that's the other point I wanted to highlight.
Balaji, just have one quick question to Professor Kamakoti. Do I have the time?
Yes, please, Akhilesh. Yeah, so the floor is yours.
Professor Kamakoti, as you rightly said, this is a moral responsibility of the citizens to use in the current pandemic situation. Look at the Arogya Setu and use it to the best possible, best available features. But what are the plans like this? This cannot be in push mode, definitely. There has, of course, cannot be in the pull either. but what are the plans to make it more effective? Because there is a audience question also on this, that the observation is that the Arogya Setu is becoming more less and less popular and less used.
Yeah, so the main thing is that one of the important criteria that we have put is that there is a sunset clause for everyone, right? So that we are ensured. So anybody can deinstall it at any point of time. There is a clear data retention policy that has been published, and those things have been maintained, and the source code is also published, so people can look at it and certainly take a choice. Now the point is that, see, the notion of trust has to be built, and I really don't know how. And people should trust. See, who is now saving you? Which hospital is saving you? Government hospital. Who is coming and monitoring you? Government police. You trust the government. If you are not trusting the government, and then just keep raising queries about privacy and other things, at this point when we are really doing a firefighting, and so that has actually pulled down. We have around 1.75 crores, 17 crore users, right, as of now. But then India is 140 crores. Okay, so we have it's only 10% of the population. But that itself has given us some, at least in cities, there have been a good usage, and it has given us. But the point is, somewhere everyone should realize this as a collective responsibility. And come out and given a very short time. Again, we did not have a year to debate about what is privacy, what is thing here, and really understand what should happen, and take what more do you think? Like you all can write an editorial. I think any daily will publish. All people are talking it. Let us go and write an editorial. What more do you think the government could have done to build the confidence among the citizens, and then go ahead and propagate it? I think we have crossed, as we see the decline in the number of cases, we may have crossed wave 1, but wave 2 should not come, and that is also very scary. And one of the things that we were all concerned, like since we have been very deeply involved in this, specifically to get out something concrete out of this, so that we could manage this pandemic, is that how do we build this trust? Every time that somebody saying, oh, privacy concern, yes, there is a balance that we are trying to hit at it. So what else would be the solution? That is, so you give an alternate solution. What will work? It has to work. It has to deliver. Okay, it should be an actionable item point, right? And so things like location information, right? How can I, if I don't collect the location, what will I do with that damn data, right? So that is the most important question. So this is something that all learned people should carefully look at it and help building the trust. And then only this in future, hopefully COVID ends. But in the unfortunate event of our country facing another pandemic, say even a century later, let us all write down what has happened here, maintain this memory, and pass these good things back, right? And I think that's very, very important, right? And that's the way I'm putting it. Right?
That's a great message, Professor Kamakoti, and that's, I think, a big outcome. Thank you very much. So I think in the interest of time, Balaji, now we have crossed the limit. So I'll invite Rajiv to do the wrap up for the session. Is that fine?
Yes, I would like to quickly thank all the panelists for a wonderful discussion, and thank Rajiv and Akhilesh for allowing me to join this panel discussion. And over to you, Rajiv. Thank you so much.
Yeah, thank you. This was a very lively panel and very good discussion. Rajiv, over.
Thanks, Akhilesh. Thanks so much. Thank you, Balaji. I think it was a very interesting session. So we've so by quick observation that we had very diverse thoughts over here in the diverse keynote talks, and of course the panelists. I think a lot of what they shared was there's not much overlap, coming from different perspectives, different companies, and different backgrounds. But again, on the behalf of the organizers, I and Akhilesh would really like to thank all of you. It's now 9:30 here, right, for all of us. So it's been a very enriching day, very productive day. Let me just again extend a very warm, big thanks to Sachin Lodha from TCS, Anand Virani from CCT, Akshay, Mishra, DSP Networks, and of course Balaji. Thanks for the outstanding panel. Again, great, sincere thanks to Professor Kamakoti. We all know that he's one of the key players in the not just Arogya Setu, but in a whole space of privacy and the proof of concept around it. So thanks again, Professor Kamakoti. Sachin, again, thanks to you, Akshay, Anand, and of course Giri. It's been we really appreciate you've been up early not only for this but for all the practice sessions. Or it's been late. You in San Diego, so thanks so much for sharing your perspective. I think it's been a great takeaway from this session. One key takeaway is that thanks to this pandemic year, it's a game changer in every sense, particularly in the context of privacy and security. I think it'll be interesting to see what happens going forward. One of the things that I am very excited about is to see how is the technical landscape going forward over the next few years. And not just technology, but as many of you pointed out, the policies. What are the policies, the framework around the privacy going forward, whether it's trustworthiness or whether it's regulatory issues or whether it's many of the issues that Anand, you, for example, pointed out, Akshay and Anand. So it's been a great evening. Thanks again, all of you. We'll certainly be in touch. And I think it'll be great if we can come out with some kind of white paper co-authored by all who participated in this panel, because that'll be a great something tangible that we'll all learn from. So thank you again so much. And Akhilesh, over to you.
Thank you very much. I think lastly, thanks to everyone. And let's over to the host, maybe.
Thank you, sir. Good evening, everyone, and good afternoon and good morning for every part of the world. So thanks for wonderful presentation and the panel session. So I want to announce for tomorrow's.
Sorry to interrupt, and Rajiv and Akhilesh, sorry, but
yeah,
we wanted to thank the audience which stayed up until 9:30 from my side. Yes. So I felt compelled to say it. Sorry to interrupt.
No, sure. Thank you.
Thank you, Chair, again. So I am to announce the tomorrow's session, that is a concluding mega session for tomorrow TTDD conference that will start at 16:50 to 21:00 hours IST. So the discussion will be on IP perspective. So please join us tomorrow's session, that is the mega session for TTDD 2020. So thank you everyone, and great pleasure to have you listen all the panelists and speakers. Yeah, thanks.
And before we wind up, Asif, thanks so much for all your help. I'd also like to thank Mrs. Pamela Kumar. So if you go back in time, Akhilesh, I and Mrs. Kumar have had some very productive discussions. Really her brainchild that we should have to have this session. It worked out extremely well. Thanks once again, and we'll look forward to meeting you in person post the pandemic era. Hopefully that'll happen very soon.
Yes, sure, sir. Thank you. Thank you, everyone.
Thank you.
Thank you, everyone. Thank you, organizers.